start.
Good.
Hi. It's exam 2 time, which means depression is kicking in right on both ends.
Nick already has a waiting.
Yes. Someone has to look at all of those exams.
I'm sorry.
Anyway, so we have exam 2, which is going to be chapters 8 and 9. So that's 17 over there. We are talking about methods of integration, and we are talking about differential equations, in particular separation of variables, right? There are other things that are in that chapter, but you will be taking the course anyway, so no need to cover differential equations extensively there. I understand that number 1 is in Calculus 1, but number 1 needs to be also written here and in red, and that is U sub. We did talk about this the day 1 of the course and said if you don't know U sub, just don't bother. What's U sub? It's different than subway. Yeah, okay.
Is that like a substitute teacher?
The next one is going to be integration by parts. Number 3, trig integrals. Number 4, trig sub. Number 5, partial fraction. Number 6, we have the, I'm going to list now improper integrals. Improper integrals, and then in parentheses, type 1 and type 2. Number 7, numerics.
For the improper ones, will you, like, this will be the improper section, so we know, or is it just going to pop up type 2 anywhere?
Type 2 anywhere for life. Otherwise, you'll be creating those batteries that are exploding, right? Type 2 for life. We talked about the importance of checking that stuff. And I did say, if you go back in the lecture, and I said today we are changing, right, the way we look at definite integral forever. So numerical integration. Number 8, separation of variables.
How many numerical integrations are you going to
1.
Thank you, Jesus. They're long.
Yes. All right, so here is the exam layout. Now, guys, we also see number 1 is from Calc 1. We also know basic integration Calc 1, but yeah, all that. Please remember that improper integrals can use any of these integration techniques, right? Improper integral is going to be, right, because improper integral is that limit, right? And dealing with limits of integration is not the way you solve the integral. So that's something that it's important. Now, 2 questions on partial fraction decomposition. Partial fraction decomposition is very long and very painful. So I lean towards a 2-variable problem or a 3-variable but joke to solve system, right? For the full problem. And then the second problem is going to be 6, 7, 8, 9 variables where you just set it up and walk away. There will be no calculations, no solving the system or anything. You just set up, you know, A over A. Yeah, you just set up the fractions and you walk away. So one-liner.
We need to integrate those.
He just said it.
How would you do it?
Which one are you doing?
The one with the 2 or 3, he's going to do it.
Is a full problem, and then the one that has 7 variables will be just set up the fractions. So I just want to know that you know, because on the top, right, you will have variables A through G, I don't know. And then once you have that, you should be able to go plug that into the computer and get the solutions. Right. So
Have linear? squared, prime,
Yes.
and prime squared.
Oh,
Yes, linear squared, quadratic prime, and quadratic prime squared. Those are the four, yes. And you will have all of them in combination, right, in this thing. So, two partial fraction decomposition problems. One is calculation, and the other one is just to set it up. Integration by parts, obviously, right? A combination between parts, between polynomials and exponential, polynomial trig, and so on. So something like that. Trig integral. Well, there might be a trig integral, there might not be, because when you do trig sub, which is guaranteed to be there, when you do trig sub, you end up working on a trig integral. So, you know, depending on how long the exam goes, it might be 8 to 10 questions. I lean towards 10 because then we can just assign, 10 each. But then it's not fair to give 10 points for setting up a 7-variable partial fraction and then running through improper integral that has, whatever integration in it. So, I have to work a little bit on it.
You could do a trig integral as like the replacement question.
Oh, thank you very much. See, solve the problem,
I
right?
like it. Yeah.
So,
Gonna have to do the
numerical integration. We have three methods we covered in class. It's the midpoint, trapezoid, and the Simpson. We have to remember that Simpson is the only one that asks us to have the even number of rectangles. And then trapezoid and midpoint can have even or odd number, right? So that's that. And then
will you tell us the method, or will you just say choose a method?
so if the problem states, right? If the problem states which method, you use that method. If it's left open, just says numerical integration, then you pick whatever you want. Yes.
You should say Simpson's rule and make it odd.
Simpson's rule and make it up?
Make it odd.
Oh, make it up.
I like that.
Then you say, can't do it, and then just walk away. All right, and separation of variables, guys, again, for differential equations, there are two different flavors. We have one that computes C and the one that doesn't compute C. So that's general solution or particular solution.
What section?
9.3
I've been doing all of those on
in the new,
so I've been good.
right?
Except for the one that has the root.
So it's in the syllabus in the last bit.
I didn't get that one.
Yeah,
The
that's
one that
the
had
one.
root 10 denominator.
Was that today?
No, it was 2 days ago.
Tell
I
her.
got half the root.
Tell her she doesn't know.
Negative
If,
answer.
if by some chance,
But I'm just
So very positive.
if by some chance you give us
Oh, it's a
Uh,
10 that's what I
a
meant.
numerical
I did not get that.
separation
Yeah, it was a
of
10.
variables.
it's guaranteed.
Positive.
We're down
No,
to about
but
20 minutes.
and you memorize what it is,
It was
and if
disgusting.
I just write the answer, that's fine.
Yeah.
Okay. The other half, I didn't.
All right.
Maybe I got-
Now let's take a look at some examples. Just a quick question. What is the integral of 1 over 1 plus x squared dx?
Inverse tangent. Got it. I am on top of that one. Thanks to that guy.
All right. Now, integral of x plus 1 over x squared dx is equal to?
Same thing.
No,
Inverse secant?
no, you have
The ulcers
to,
were flat.
you have to do a U sub on that one.
Yes, we do use sub, so it's ln, right?
Yeah, it's an ln.
1/2 ln of 1 plus
Out
x
of
squared.
curiosity, for all the other inverse trig functions, can you use trig sub?
Yes.
So that's why we only need to know the inverse tangent.
Yep.
Okay.
Well, no, you can do that one too.
Could you really?
Yeah.
Okay.
I
so
bet
that
you
would
could
work.
set up
Because,
the
yeah,
exam as
you
one
can
of
do it.
those extra ones, like,
Right.
3 plus 5 is equal.
And then you would square this one to kill the root.
Yeah. Got it.
Anyway, all right. Just wanted to point that one out, so make sure that you guys are good with that. Okay, so I have a plethora of questions. I haven't used that word in a while, so there we go. Do I have to sign these or just use it to
No,
flip?
those are the
Oh.
stickies. I got extra ones, so
Oh,
I
okay.
use those up because I don't need them.
So the question is where the sticky is, not on the
Yes.
next page. Okay, got it.
Like how you.
And then I have a whole bunch of other questions which are cool. So let's see what we have here on the pile. We have this one. We have this one. We have nice. These are shiny. The integral of 3x cubed divided by square root of 7 minus 9x to the fourth dx. What is this?
Trig sub.
Is it trick sub?
That's trig sub.
Yes, this is just
Yeah, trig sub is going to be really painful. How about u sub?
Yeah, I was gonna say trick sub seems really annoying. You have 7 there first of all.
Well, it's a root 7. You just carry
but
root
also
7. It's not a big
four
deal.
terms there, and it just seems annoying.
7 minus 9x to the fourth du equals negative 36 x cubed dx. So
Okay.
we need to multiply by negative 12, right? And done. So this is we're going to call this done, right? Are we calling this done on a u sub? Or we negative 1 over 12 integral of du over square root of u, and here, and then we put the Nike symbol, right? Just do it. Well, you will go home and you will practice, right? So that takes care of one question. No coughing. Next one. I think this says 70.
Yeah.
Great. So we kick 70 outside of the integral. We have a sine to the fourth x cosine cubed x dx from pi to 3 pi over 2. You remember this one? Ah, it's
You take cos squared.
excellent. So we see that we have the odd exponent.
Yeah.
We peel one off and then transfer the other ones. Guys, the problem is done over here with different powers. The problem was done on the board. You guys already enjoyed something like this.
So what do you think about the answer that they got us on the,
What happened?
what do you think about the answer that the online thing got?
Yeah, no.
No?
So we have sine to the 4x, and then we have 1 minus sine squared x, and then we still have a cosine x, and then we have dx. So now we have a 70 integral pi to 3 pi over 2, and then I have sine to the 4x minus sine to the 6x cosine x dx, and then we just hit it with a u.
You're not going to give us any of the ones that simplify down to just...
How do you know?
To just cosecant theta or
Or
just
just,
secant theta, because they're not...
You're giving me ideas.
or just
So-
theta. I like that.
Test should already be made up.
It's not.
Just,
I procrastinate.
you know how it just cancels out and all you have is
Yeah.
theta? Yeah, there you go.
Those are nice, right?
Those are wonderful.
Wonderful, wonderful. So now you have 70 integral of u to the 4 minus u to the 6 du, and then boom. Excellent. Next one. Oh, well, these are dropping like flies. Integral, 16x squared minus 49, boom, divided by x cubed
Oh,
dx.
and x goes to something?
That's just that the domain is x larger than 7 over 4.
This was off the
That
quiz
was a
today.
pain in the
It wasn't bad.
Let's fix them.
It was annoying though because I forgot the cube on the 3.
Yes,
I put it squared by accident.
So you said you like this one?
Square root should be down below.
He doesn't like that.
Let's,
Definitely a typo.
That was hilarious.
Type that on the test.
And then he was like, are you sure we could do that?
let's see.
If you give me this, we're just gonna flip it and then do it that way.
So
What do you do with that?
we are going to draw the triangle. We put our angle theta. Now there is a minus, which means that our hypotenuse is 4x. And then you can put 7 on one of the two. Where do you want 7? On the bottom? Okay, fine. And then this one will be square root of 16x squared minus 49. So now we do the red equation over here. And then we do the blue equation over here. So the red equation is that the cosine theta is equal to 7 over 4x, from where, so now we flip both sides, so secant theta is equal to 4x over 7, from where x is equal to 7/4 secant theta. And dx is immediately 7/4, then derivative of secant is?
Theta tangent.
Very good. D theta at the end. So we are done with red. Now we jump into blue. Blue equation is going to be the tangent theta, which will be the square root of 16x squared minus 49 divided by 7. So the square root of 16x squared minus 49 will be replaced by 7 tangent theta. So now we go and we replace all of these in our integral. Integral is, and then we have, instead of the square root, which is in the numerator, we have 7 tangent theta. Instead of dx, we have 7/4 secant theta tangent theta d theta divided by x cubed. So that's going to be 7/4 cubed secant cubed theta.
We simplify and pull out the,
Well, you can cancel out the secant, and then you only have 2 on the bottom.
Yes. So now, what are the things that we can kill over here? We can definitely kill one of the secants. We can one of these 7/4, and then we still can kill one of the 7s. So it's going to be 7 over 16. No, we kill one of the 7s. It's going to be 16 over 7 because it was in denominator. Integral. I have tangent squared theta over secant squared theta d theta, and that's the only thing that's left, right? Now,
break them apart into its components.
yes, sine, excellent, you got this, 16 over 7 integral sine squared theta over cosine squared theta over 1 over cosine squared theta d theta. Cosines die, and then what happens?
It's just sine squared theta and cosine.
You know what I forgot? I forgot 70.
You're right.
Dun, dun, dun.
Minus 10.
So,
What? 70 was in the last one.
This was the last
No, that was the last
Yeah,
one. You're
there's
right.
no 70 in
oh, there's no 7 in this one?
No 70. No, we're on the next one. Yeah, you went a little too
That
fast
was
here.
the last
Talking about the 16. There was another 16.
That's okay. Yes, there's no 7 here. Yeah, fine.
So you're gonna have,
So we have 1. Help me.
It's just
What?
integral
It's just
sine
sine
no,
squared
squared
it's
theta.
sine squared.
Yeah, help me.
Right, so it's that.
and then so it's cosine.
So what is it?
Cosine.
1 minus 1 minus.
Ah,
Well, yeah, the over 2
Yeah,
theta
that part.
divided by 2, and then you take a half out.
Yeah, and then you have to use a double.
so that's gonna kill that 16 is gonna be 8 over 7. The integral of 1 minus cosine 2 theta
Then you have to use a double angle.
d theta, yes. So 8 over 7 theta. Integral of cosine is, so minus sine 2 theta over 2, right? And we still have to go back to original x values because we got limits on this one, right?
Did we?
No.
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 Theta, cosine theta.
I failed again.
Yeah, then you're gonna separate it.
And then
So
it
now-
goes away.
8 over 7 theta minus sine theta cosine theta. The
Two's
two,
canceled.
yeah, 2's canceled. Nice. And we just need to read. Oh, there's a plus c.
Plus C, yeah. And then convert back and then distribute.
Yes.
Or
So
you could have just did two
So,
integrals.
theta is what? Inverse tangent of this? No. Inverse secant? No, even cosine. How about inverse cosine? Inverse cosine 7 over 4x. Inverse cosine 7 over 4x. Minus, now sine, when you read the sine over here, sine is square root over 4x.
Where'd you get sine from? Oh, that sine.
Square root over 4x. And then this one is 7 over 4x. Plus c, this is 16x squared minus 49.
Then you distribute the 8 over 7 if you want.
No, you can leave the 8 like that.
8 over 7. Cosine inverse 7 over 4x. Minus 7 square root of 16x squared minus 49 divided by 16x squared plus c. Wonderful. That was a good question.
I
Yeah,
think one of the ones I had is like that.
great. We got that one. What is this? Dave. Integral 0 to pi of 9 sine theta divided by 1 plus cosine squared theta d theta.
You can take. No, you can't. Can you take a 9 out?
Yes. We can kick 9 in front of the integral here. There we go, gone.
So you have it's du over 1 plus u squared. You do that?
It's some messed up trick stuff.
Messed up tricks up.
You can't U it?
And you take
No, because that'd be the negative.
I think it's one of those ones.
But that's an identity
Is it
right there.
What's identity?
The 1 plus cosine.
Well, that's gonna.
Isn't that 1 plus cosine 2 theta?
Sine
Oh,
squared,
okay.
cosine
Just
squared.
put a negative somewhere.
So shouldn't it be sine theta over cosine squared theta?
What happened?
Oh, yeah.
Oh, okay. So what should what is the answer?
You sum. That's all it is. Yeah.
Yes.
That's
Yeah.
exactly.
That's
what
what
I
you told
say all the
me.
time.
No, I'm just playing.
But
Can you
seem
not?
like we were wrong.
So u is cosine, and then du is negative sine. These are thetas. Theta d theta. We need a negative, so we'll install a negative. There we go. And now this becomes negative 9 integral of du over u. No, over 1 plus u squared, which is negative 9 tangent inverse of
Nice.
cosine theta from 0 to pi.
Dude, he writes quicker than I can write, so I.
That's why I don't write it.
You just absorb it.
I do it. I write it at home. I mean, I print it at home.
You take the notes home.
No, I print it.
So negative 9 inverse tangent, and then we have a cosine of pi minus inverse tangent cosine of 0.
How do you do
Oh, you backtracked, you didn't change the limits.
Yeah, we could have. Fine. So negative 9. Cosine of pi is? Very good. So tangent inverse of negative 1 minus tangent inverse cosine of 0 is? Excellent.
How'd you get a negative 1?
Cosine of pi is negative 1. And now, negative 9. And over here I have negative, so negative 1 is at pi over 4, right? So we have negative pi over 4 minus another pi over 4. So all these negatives make a positive. This is pi over 2, 9 pi over 2. Good enough. Sign here, okay.
Is there any of the, I forget what they're called.
Differential equations? Sure, right now.
No,
Yeah.
those are not bad. I'm talking about the,
Divergent.
yeah, that.
Improper?
We had those.
Improper,
Yes.
There should be somewhere over here.
I don't know. I can't remember.
General solution, express solution, okay, good. So,
What, ham?
y prime cosecant t, yes, is negative y to the 7 over 6.
You just make those x's.
Yeah, you should just change them to axes.
Then please don't take differential equations, because the whole course is in terms of time.
Well, no, I know, but I'll convert back after the equation.
And you want to do that for the entire course?
Possibly.
I know
I'll write a program to do it.
You write a program to do it, I love it.
Is this the separation of variables you're talking about?
Yes,
So that's differential equations.
yes,
Very basic, yeah.
Nick,
9.3,
Nine.
boom.
Nick, the way you wrote this, is this y prime of cosecant t or is this cosecant
Times.
y? Okay. Just make
So what I'm going to,
So that-
well,
that's fine.
this is not the way I wrote it in class, so of course it's confusing. So here it is, dy
Yeah,
dt
there we go.
times cosecant t is equal to, and I'll put this as negative 1 over 6 y to the 7. All right.
The way it's on MATLAB is very confusing.
If I have this memorized,
I don't like my
if,
friends.
are you going to give something like that?
Well, this is a procedure. You just separate the variables, you integrate both sides.
Okay.
You can't memorize because it's just one thing changes, the interval changes.
It's supposed to be a normal one.
Yeah, but this is just one example out of
Well, yeah,
5,000.
but if you change the 7 and the 6, I still know what to do with
Looks like a
them.
Wolfram Alpha.
Or if you make
All right.
it secant or sine.
So what do we have?
1 over cosecant is equal
We have,
Oh, right. You're gonna have sine on the road.
so yes, so now dy stays on the left, joined by y to the negative 7, right?
Yes.
And then on the right hand side we have a dt, with negative 1 over 6 is going to stay there. And we have a cosecant that goes to the other side, and I already heard you guys say sine t, so I'm happy.
I know what the answer is.
You?
Y is equal to square root cosecant t plus c.
See?
Okay. See?
6 root.
6 root, yeah.
So we're going to integrate both sides.
And you are.
Oh, I love you guys. Integrate this one, y to the negative 6 over negative 6 is equal to negative 1 over 6, and that's going to cancel. And then we have a cosine, no, negative cosine, right? Integral sine is negative cosine, there we go, of t plus c. So now this negative over 6 cancels, and I have y to the negative 6 is equal to, on the other side, I have negative cosine t plus c.
did you want us to,
So now we have to fish out
yeah,
the
exponent.
exponent. So this is 1 over y to the 6 is equal to negative cosine t plus c. If you flip the left-hand side, then you have to flip the right-hand side.
And then it's 6 of the denominator.
And then we take the 6th root, yes.
You were wrong, bro.
Why will
Are you sure that's right?
that be
No.
negative?
What happened?
Why will the cosine be negative? Won't the negatives cancel out?
There is a negative from 1 over 6. And then there is, when you integrate sine, it becomes a negative cosine, right?
Yeah.
So the negative 1 over 6 on the left and the 1 cancels. Yes.
Is there a red box on there?
I don't know what. This is what you have.
Oh, okay, I see. Yeah, that was my question. Why do you have to put 2?
Because the 6th root. You take a 6th root, you get positive and negative.
Oh.
So I should put plus minus here. But.
Oh, okay.
All right.
Gotcha.
So okay, you did this, you did this, you did this. Okay, that's done because 2 of these have the same problem. All right, good. Off. Let's see. Packet number 2. We got this one. Nice. Ah, beautiful. Another question. Integral dt divided by t squared square root of 36 minus t squared. Triangle. Theta. 6t square root of 36 minus t squared.
You like this one?
We do?
Yeah.
All right. So we have the red equation, which is going to be our sine equation. So sine theta is equal to t over 6. T is equal to 6 sine theta. And finally dt immediately is 6 cosine theta d theta. Blue equation is going to be the cosine theta, which is square root over 6. So that's 36 minus t squared. So square root of 36 minus t squared is equal to 6 cosine theta. So now plug everything in. Integral dt is 6 cosine theta d theta divided by t squared. That's going to be 36 sine squared theta because you have to square both sides to get t squared. And then square root is 6 cosine theta. All right. You don't like this problem? Oh, you do like it. So these cancel. 1 over 36 gets kicked outside, and inside we have 1 over sine squared, which is very good. So now it is, yes, it's the integral. This is a basic integral, right? So negative 1 over 36 cotangent theta plus c. Now, cotangent is what? Tangent is opposite over adjacent, so cotangent is adjacent over.
Will that be a negative cotangent or just positive?
It is negative right there.
Yeah, he put the negative.
Oh, you already pulled it out. Sorry.
36. Adjacent over opposite, so that's going to be a square root of 36 minus t squared divided by t plus c, and there we go. We walk away. This was a good question.
See, questions like this show you.
I know, too bad we used it up for a review.
Terrible. Terrible.
Then we should have made the review extra spicy.
There's nothing on this one, Walter.
Oh,
Are you
sorry.
gonna do any of the other ones?
I hope so. I don't know.
Or we could do any-
I follow where I'm supposed to sign.
Which one?
The ones that.
This is another trick question. We had enough trick.
That's the one that I said is going to be the same.
Yeah. Now, was there anything else?
Diversion is what chapter?
We're gonna find. Oh, here's differential equations with calculating value of c.
That's the one.
Yes, that's what we like, right? Now you hit this staple
Fine on all of them.
in a very unfortunate manner.
Just rip it.
All right, let's
Except the one
go.
with the
Got it.
10th root in the bottom because I forgot. Since
I
it's
didn't do it
positive.
today's one.
No, since it's, yeah, what?
I didn't do it.
Today's was bad.
Ty prime of t is equal to 1. Y of 1 is equal to 3
I did like this.
for all t is bigger than 0.
So at least
Excellent.
that was me. That was the only one I had.
And then this one is done. Look at it.
Okay.
So, t times dy dt is equal to 1. Separate variables. So dy alone is equal to 1 over t dt. Integrate both sides. The y is equal to,
ln absolute value t.
thank you, ln absolute value t plus c. So now, this would be the end of the story because this one is what we call the general solution.
Okay.
However, we do have initial condition that y of 1 is equal to 3. Now, what this means, for those of you who didn't get it, is that the t is equal to 1 when y is equal to 3, and you need to plug in.
C equals 3.
So, if y is equal to 3,
Okay.
then you have the ln of 1 plus c. ln of 1 is 0, so c is 3.
That's how they got.
So now y is equal to ln absolute t plus 3. Now we get to box this one because this is the particular solution they asked for.
Okay.
This was off the lab, wasn't
No, that was actually a quiz.
Oh, here is the another question that is the same as the one we did.
Yeah.
The quiz question, I got this one, like the exact same one.
it? Oh,
same
actually, it
values
was
and
a quiz.
everything.
Yeah, it was a quiz.
And I did it right, but it said I did it wrong.
Because the quiz people are stupid.
Well, it looks like
Yeah,
that's what
like-
you do in the quiz then, huh?
Yeah, my math
No,
doesn't
but-
quite like absolute values all the time.
It doesn't. It's just,
I put the
It's
absolute
done.
value in and it's like, nope.
Such is life, huh?
Wouldn't it technically be
He
wrong?
doesn't care.
They didn't specify t had to be greater than 1, so is that? Necessity for the absolute value?
Yeah, because, yeah. This is, okay. Oh, nice. So we have another differential equation. This time initial condition is not given to you. Therefore, you are only supposed to do separation and then solve it. So let's go. Go. Go.
This is the one that I was talking about.
Whoever gets the solution first wins the
I already
prize.
got the solution. But this is
Doesn't
where
have
my
to be the
question
right
is, why is the C in the front?
that's because it's an E, because it's a plus.
No, I don't understand.
So it's C, E to the 4.
The answer is C,
No.
E to the 4.
Because it's
remember
in-
the solutions to all of these equations?
Absolutely, it's all in here.
Did you do this stuff,
Like a
man?
sponge.
So was this the entire weekend to do just memorize the solutions to every single differential equation you ran? Holy man, I've never seen this.
Because it's E plus an E. So since it's E plus an E, you have to multiply the E's together.
The exponent is plus, so
Right.
yes.
I just said it's this morning.
Yeah, it's a quiz.
Yeah, it was just
Yeah.
morning.
Son of a. What did you give? He says it doesn't matter what we see.
It's
No, it doesn't matter.
Over 3 plus 6x plus C.
Yes.
But it has to be
E times 4x cubed over 3
whatever.
plus 6x
You're
plus C.
right. That should
Yeah.
just be
Or
multiplication of the
E, is it E to that or is it E times that?
E to the power of
E to the power of that, right?
Yeah, because you have to
If
bring them.
anyone hasn't done the quiz yet for today, this
Oh
is
yeah, I
on.
hate E.
I'm gonna start.
Wow, I hate E.
How's it going? I'm good. How do we solve this?
Wait, we don't need to find C, right?
No.
Okay, good.
Yeah, it's just, it's so silly.
Is this a weird end?
I got it. 10 points.
10 points?
I'm done.
Look at you guys fly. Let's see if I can match that enthusiasm.
You know why? It's because
I got one question that everyone
differential equations are almost like a pattern.
Yeah.
Once you get one of them,
You get all of them.
you got all of them.
Yeah, I'm like.
Exactly. All you do is change the numbers.
Yesterday.
dy over y is equal to 4x squared plus 6 dx integral. We have ln of y is equal to, now integration over here is, I almost got killed over here, plus 6x, right? Plus c,
Yes.
right? Plus c. Now we're going to
E both sides.
e both sides, nice. And then we just get y as a function of x in this case, is equal to e to the 4/3 x cubed plus 6x, and here is, I'll write it times e to the c. So you are using the formula from algebra, which says that x to the m times x to the n is x to the m plus n. We're just using this formula backwards because this is what we have, where this n is c. So we can, right, and now we're just going to call this a capital C, e to the c. So y of x is equal to e, put the c first, c e 4/3 x cubed plus 6x.
Does it matter which is written first, the C or the E?
It just looks weird if you have it this way.
Okay.
Would it be right?
Yeah, it would. Just put the c in front.
Oh, the C goes in the front.
10 points, 10 points.
See, that's another good test question.
Yeah.
I hear you.
I like this. This is nice.
Extra credit.
See, if you give us a differential equation that's like this,
We'll all pass the test and we know the material.
if the exam is like the
It's a
quizzes,
win-win. It's the purpose.
I'm golden.
Nick, out of curiosity, how do you know if it's separable or not? Because there's a couple questions that popped up that's like,
Well, you can't, if you can't separate them, it's not separable.
okay, that's all that means.
Yes, that's the only, right? Because if
I
they,
haven't had one yet, though.
I had a couple.
because,
Give me an example
Because
of a
otherwise
non-separable.
it's just gonna be too simple.
Can we go over like the type 1 and type 2 with the problem?
Yeah, I already gave,
Just, alright, just make sure.
Yeah,
I don't
yeah.
forget this.
yeah, I gave them both.
integral 3 to infinity, for those of you who couldn't wait.
Yeah.
So rejoice. Cosine of pi over x divided by x squared dx. So what we have over here is the improper integral of type 1, y1.
Because it has the-
Because you can see the infinity, you can see the problem, right?
Well, type 2 is with numbers, not.
Yeah, type 2 is the evil one.
So we should always check that regardless of the problem.
Yes.
Check what?
You see limits of integration, you see a definite integral, you immediately have to check for improper part 2.
So, okay, so anything that has, okay, so
Anything that has, yes, you have to check for limit.
as long as, it- yeah, as long as.
I can make this problem much worse by replacing one number.
Yep.
What should I replace and make this much worse?
3.
Replace 3 with what? With 0, exactly. Replace 3 with 0.
Now it's both of them.
Yes! Now, this is type 1 and type 2. Because it's type 2 on a 0, there's a vertical asymptote, and it's a type 1 because of the infinity on the top.
Yep.
What do we do now?
We're not...
This is the stuff that we don't like.
This is the one that you use as a replacement.
This is when you change careers, my dude.
This is, yes. So you see this and you change your career, exactly.
Out of curiosity, the ones that are gonna be, say, on the exam, are you gonna have one where it's both go to infinity? So like, we would have to divide.
Apparently that's the next question, so I will have to.
Look at his face.
Oh man,
He's like-
he is now. Oh yes, I like those because it's easy. All right, great. So the first order of business is to kick 10 outside. Then I'm going to put the limit. B goes to infinity. That's the upper limit, right? We have a B and there's a 3 on the bottom, and I have a cosine of pi over x divided by x squared dx. Great. So now my integral went from being an infinite integral into being a finite integral. And the question is now, how do I integrate this? U sub?
Pi over x.
Oh, okay. What's the U? Very good. Dx.
Wow. I like that.
I would not have.
I would not have done that either.
I don't know.
Well, good thing we have Wolfram Alpha
Is that the
to help us learn.
You didn't have a lot of options. You had to pick one of those.
You do not have options here. You just see 1 over x and 1 over x squared. They are derivatives of each
exactly.
other.
You know
You
what I
do
mean?
not have any options.
Eventually, you're just like, I'll try u subbing pi over x, see what happens. And then it happens.
Well, I mean, you're not going to try partial fraction decomposition. You see a cosine up there, right?
Right, you know.
There are no square roots and stuff, so it's not going to be a trig sub either.
You can kick a 10
It
out.
can't be by.
I did.
Where'd you kick it out to? Oh, there it goes.
You can't do by
When we're doing the
divide.
integral things, right,
Can't do
and it
by
has
part
the
divided.
limit things,
Technically,
do I
you
have
can.
to write
can use
every
1 over
limit?
negative
Can I
x.
just do the sign and at the end
Or
put
you
the
can use
limit?
like 1
You
over.
turn it into a negative x.
Why? Why would you do that to yourself? Then you forget the limit and then do
No,
what?
because what I
Could
do
this
is I
work with
click
by
quick on the top.
Could this
Oh.
work with by part?
So I know that it's
Okay.
limits.
I
This is a
see.
pain in the ass, don't you know this?
Well, such is life, right? All right, let's go. 10, limit, b goes to infinity. And now, look, I need a negative pi. I don't have negative pi, so I have to install negative pi, and then I have to divide by negative pi. So there's going to be a negative pi over here. Negative 10 over pi. There we go. Now is the integral. And this becomes cos u du. Wow. Isn't a u sub the greatest thing in the galaxy
Can
ever?
you actually do this with by parts? If you take like 1 over x squared and then
That's your homework assignment.
No,
Yes.
no.
Bring it next class. So
What happened to the negative? For the, in front of the cosine?
That went out.
Already kicked it out. It's on the 10 now.
Minus 10 now.
Oh, okay.
and I have integral of cosine is sine, so sine, and then u is pi over x. And we have our limits 3 to b.
Oh, you didn't change. You didn't bother changing the limits.
No, because I have to go back because of the limit.
Yeah,
Limit b goes to infinity. So negative 10 over pi,
Infinity.
limit b goes to infinity
Couldn't you put b
of
where x is?
sine pi over b minus sine of pi over 3.
Yeah, so it'd be pi over infinity.
So what's pi over infinity?
What would you get?
0.
Yeah.
So So now we have 0 minus sin pi over 3 is? Very good.
But that's what I said, technically you could do that. couldn't
Yeah,
you? So it's
technically, but
negative.
then you're just.
So we have negative and negative will cancel. We have 5 root 3 over pi.
No problems.
Converges. Oh, remember this problem? It comes back for the series, right? Integral test? Same problem.
Oh, you need to change that homework also.
I will.
Thank you.
Are we all good on this one?
Yep.
Sure.
Is there any way we'll have to use walking tile?
Yes.
Every single time.
Can we?
Can we? I don't know. If it comes up, sure. Unless you have a problem. Ooh. Well, thank you, Olga. Look at that. Negative infinity to positive infinity x squared plus lock the doors.
That's a trick.
What is this?
Improper trig.
But part 2.
Yes, improper type 2 with trig substitution inside. Or is it?
Okay.
Or is it?
Is it type 1?
Arctan. Arctan.
Yes. So we don't have to do trig sub. If you know that this is inverse tangent, just write it out.
How do we know that
It's x squared plus 1, but what do you do about the 25?
Yeah.
It's just 1 over 5. That's the A.
Come on, you guys don't know Arctan?
That was
Oh, Angelo, you are amazing, man. I love it. You guys don't know Arctan?
Does anybody want numerical?
All right, so we have.
Not really.
No numerical? Okay.
We can do one Simpsons rule because it hasn't shown up once on any of the quizzes.
Because they're so easy.
So, do we all understand that we have to break this one? We have to break this one at 0, right? I mean, you can break it at pi over 2, or if you like pain, right? But we break it at 0. And now we have limit a goes to negative infinity, a to 0, dx over x squared plus 25, plus limit b goes to positive infinity, integral 0 to b dx over x squared plus 25. Now, we have to integrate this. So what is the integral of this? So first of all, what is the integral of 1 over x squared plus 1 dx? Inverse tangent, right? Now, what is the integral when you have a squared? And this is the one that is listed in your table of integrals. So it is 1 over a tangent inverse of x over a plus c.
Oh. Oh, that's simplifies things.
That simplifies things greatly, so you don't have to go and plow through all the trig sub, right? So this is the formula that it's given to you in a book somewhere for inverse tangent calculation, right? Now, I go and I say, limit a goes to negative infinity, and now this is 1/5 of inverse tangent x over 5 computed from a to 0 plus limit b goes to infinity of 1/5 inverse tangent of x over 5 computed from 0 to b equal. Now what I have.
After this, just for the heck of it, can you do the trig sub to get that?
Of course. Phew. Limit a goes to negative infinity, and I have 1/5, and then tangent inverse of, and now I plug upper limit, so that's going to be tangent inverse of 0 minus tangent inverse of a over 5. So now formula is gone. Plus limit b goes to positive infinity of 1/5 tangent inverse of b minus tangent inverse of 0. Now, every tangent inverse of 0 is 0, so we don't have to worry about that. And now,
B over 5?
b over 5, that's what I said, please pay attention. So now, we plug in negative infinity, so negative and negative will cancel. What is inverse tangent of positive infinity? Pi over 2. So we have 1/5 pi over 2 plus another 1/5, and there's another pi over 2 here. So this is pi over 10 plus pi over 10, which is pi over 5, converges. Excellent. Now, we have a request to actually take a look at the integral without the formula. So integral of 1 over x squared plus 25 dx. So we do the standard.
No, but instead, can you sub in for 25 just a squared and solve that way?
You want a squared here, sure.
Or something.
Not a problem at all, a squared. So this is going to be my x, this is going to be a, and this is a square root of x squared plus a squared. This is how we actually solve the mathematical formulas. So now, what do we have? We have our, remember that we are supposed to circle towards the number. So we have that the tangent theta is x over a, from where x is a tangent theta, and dx is a secant squared theta d theta. Blue equation is cosine theta is equal to a over the square root. So if you flip both sides, so square root will be equal to secant theta, a secant, that's what I said. And now we plug everything in. So integral, the dx is a secant squared theta d theta. X plus a squared, well, we have to square this, so that gives us a squared secant squared theta. So now this becomes 1 over a integral of d theta. And integral of d theta is 1 over a theta plus c. And then this is equal to 1 over a, and theta from here is the inverse tangent of x over a plus c. And we just derived the formula.
There you go. Give us something like that.
You're saying give us something like that as the derived mathematical formulas. Okay.
Just something like that.
All right.
Wait, so you split that whole thing again because it was a square root originally? Or because it wasn't a square root? It wasn't a square root.
That's why I squared it. See, when I plugged in, I don't have a square root here, right?
Exactly.
So, but I do have a square root here. But do you see that these are both squared?
Oh, I got you.
So that's where the,
You squared the whole thing.
yes, you square to kill the root because you can't use it with the root.
Okay, got you.
On the previous notes, he just made a 2 in purple. That's what I did over the weekend. I rewatched. And you should see the notes on your notes.
The next question is the question that we are going to do partially. Because it says apply midpoint and trapezoid rule to the following function, approximating 4 rectangles, 8 rectangles, 16 rectangles, and 32 rectangles.
Hello, homework. You see what you make us do?
That was on the homework?
Yes.
I didn't see. I would have done that problem.
You already wrote the code for it, so what are you complaining about? It's like, you're the only one who didn't do any of this by hand.
You can change the rectangle numbers.
I will change them to 6.
That's fine. I don't care.
All right.
It just gives us the midpoint and the trapezoid
On the
together.
quizzes, it was, I think it was 1, 2, and 4.
I
or 8.
know. They
That
were
was
like
nice.
1, 2, and 4. Did you know that there's a calculator online? That's
I
a
know.
midpoint
That's how I check.
calculator?
Oh, yeah, I found that.
Yeah.
The calculator mod.
Really?
And there's,
There's a
yeah, it's
calculator
called
for
midpoint
everything.
calculator and trapezoid
The
calculator.
Why would you have told me this?
I wrote that.
This is information I need to know.
That's the only
Now
way
that
I
I think
can
about it, I
check
could
to
just
see if
change
it's
the
right.
software
And
in my
then
program.
I see it's
Quiz
wrong,
time.
and then I put the right one in.
So check on the print.
Oh, you put it on.
All right.
Ian, that's nice.
So, hello to some tedious calculations that we are going to do now. The delta x calculation for all 3 rules, midpoint, trapezoid, and Simpson, is exactly the same.
B minus A.
Delta x is b minus a divided by n. Very good, which is 4 minus 0 over 6, which is 2/3. Excellent.
So what if instead of having a problem like what she said where increments by those absurd numbers, we can do a basic number of 4 but use all 3 methods?
Well, that's why I changed it, because it used to be 4. And then I saw limit 0 to 4, and I said, it's just going to be 1, so it's not interesting. So 2/3, right? Because we're going to do subdivisions now, right? I'm going to have 0, and then 2/3, and then another 2/3 is 4/3.
You want us to write this out on the exact?
If you want to.
We don't have to.
Then 6/3, no. 8/3,
I love Angelo. Why is he doing this?
10/3,
Break it into 6, all right.
You can
12/3.
that way, but
1, 2, 3, 4, 5, 6. That's it. And 12/3. So now look. When as you just kept adding delta x or 2/3, look what you hit, right? You start at 0, which is 0/3, and you have that at 4, right? And you do have 6 of these in the middle. And here's your 2. Now number 1 is in between over here, and number 3 is in between. But who cares, right? Great. So now we have our divisions. For the midpoint, I have to calculate all the midpoints and then times delta x. So what's M6 equal to? M6 is equal to delta x times f of x0 plus x1 over 2. So that's the midpoint. Plus f of x1 plus x2 over 2.
you already got the midpoint.
Plus f, I do have the midpoints. x2 plus x3 over 2 plus
Yes.
x3 plus x4 over 2
We don't need to write all this.
plus f x to the x4 x5 over 2 plus f over x5 plus x6 over 2.
That's the only way to keep it straight.
I keep it organized.
Yeah, because if you don't do that, it's going to be really
I
hard.
do it in a line.
It's not hard, it's just annoying.
It is.
You keep track of
Because you got to.
All right, so now I'm going to use my red color to get all of the midpoints. That's a midpoint, clearly 1/3. That's a midpoint, it's a 1. That's a midpoint, it's 5/3. That's a midpoint, it's 7/3. That's a midpoint, it's a 3. And that's a midpoint, it's 11/3. So I am calculating my M6 as delta x is 2/3, f at 1/3 plus f at 1 plus f at 5/3 plus f at 7/3 plus f at 3 plus f at 11/3. Now f is unfortunately not really friendly, but this is actually designed for something like this. It is e to the negative. You know what? I'm going to take this 4 outside, so I'm going to worry about times 4 at the end. So this is going to be now integral, and then we have e to the negative 2 times 1/3, right? Plus e to the negative 2 times 1 plus e to the negative 2 times 5/3 plus e to the negative 2 times 7/3 plus e to the negative 2 times 3 plus e to the negative 2. I'm just going to shoot myself. Turn 3.
Now you know how we feel.
So now this is 2/3. And now we have to calculate all of these. Just use some decimals over here. Let's see what we get. Clear. E raised to negative 2/3. I'm going to actually use the function feature to calculate this because I don't want to do this.
Is that a scientific calculator?
No.
Yes, it is.
TI-83. It's graphing calculator.
You're not allowed to use that in this class.
Exactly.
What do you mean I am not allowed to use this in this class?
It says it on the syllabus.
Yeah.
And I
There's nothing in the syllabus that says that I can't use anything.
It says do not use.
Ah, really? So we have e raised to the open parenthesis negative 2x. Great.
We can just 1 decimal, right?
Yeah, we can use 1 decimal. We can use 2. We can use 5 because it's gonna be a table feature, so it's very easy.
I bought a graphing calculator, didn't like it, so I started. I love it.
So now we have second quit. Now we go to table set, and what do I want? I want to start at 0, and I want my increments of table to be 1/3. So 1 divided by 3. Good. There we go. And then I go into second quit, second table. Great. All right, so at 1/3 I have 0.513, let's say 3 decimal. At
I just wanted like
That's amazing.
what happened?
That's what this is.
You actually have to do 2 decimals because it's going to get.
trying to beat him, but I screwed it all up.
So now 1 is plus 0.135, and then 5/3 is, so that's
What are you using?
It's gonna be 0.6944833501.
as the final answer.
No, now then you have to multiply that times 8/3.
8/3.
Wait, what?
Yeah, because there's a 4 in front of the 2/3
Oh,
and then
that's
4.
right. That's
The answer's
I
gonna be
already forgot about the
1.85195556.
1?
1.8519556.
Okay.
He has the answer there, that's what he's doing.
So I have my 1/3, 2, 3/3, 4/3, 5/3, 0.036 plus 6 7/3 is 0.009, and then 0.002 plus, these don't even matter anymore.
It just alternates between normal and
Yeah, this is way too small. No one cares. Plus, whatever.
very annoying.
All right. So, and then we need. You know what? I'm gonna change this into 8 because we know that we need to multiply by 4. Okay. So.
That actual company, that's what they do.
Why did you change it to 8?
Because there's a 4.
There is a 4 in the integral.
Oh, I see.
Yeah.
So 4 times delta x is 2/3 times 4 is 8/3. That's why. So
You get this one. And it's
13
equal to 2.
plus
Swear to goodness.
135 plus 0.036 plus point.
I don't know if this is for here. There's a lot of calculus.
It's fine.
Times 8 divided by 3. My answer is 1.853.
Yeah!
Good. Now that's midpoint. Let's do trapezoid.
Oh my God.
Well, it's the same thing, it's just a 4-2, 4-2.
No,
No, it's not divided by 2
Well,
at the end, but change it.
That's not, that's suggested.
It's 2
And then
times the
The
function.
2's in the middle of it.
T6 is the delta x is divided by 2. Simpson is divided by 3.
Yeah,
Right?
I know.
And this one is 1, 2, 2, 2, 2, 1, right? On the pattern inside.
I'm not worried about this.
So we have f of x0 plus 2 times f of x1 plus 2 times f of x2 plus dot 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 plus f of x6, and we're over. So T6 is delta x, it was 2/3 divided by 2 is a 1/3 now, and then times, remember, times 4, so 4/3. Wow. Now, function computed at x0, so that's e to the negative e to the negative 2x.
Oh, I meant your limit.
Or even
Oh, 0, right?
You're on 2, 0.
I'm gonna draw here. We'll do the limits again over here. Maybe some have to see it again. So I started my 0 limit, right? So this is gonna be 2 times negative 0.
No, but
So and then I go
0 to what?
2/3 to 4. 4/3, 6/3, 8/3, 10/3, and 12/3, which is equal to 4. So for trapezoid and Simpson, guys, you are taking the A plus delta x, delta x, delta x. So you are going to hit every single one of these numbers for Simpson and trapezoid. For midpoints, you are hitting in between.
Yeah.
So now I go and I just calculate all of these values.
For the midpoint,
So I have,
for the midpoint, if you get the first midpoint, off that first midpoint, if you increment by delta x, is that the same thing?
yeah.
Yeah. So why do you bother?
He's just doing that to show us.
Okay.
Yes. So for the midpoint, you can calculate the first midpoint and then increase that midpoint by delta x to get each one.
Yeah.
Well, that's why you do computer science, because of these are e's, not 2's. Negative 2 times 4/3 plus Negative 2 times 2.
I would need the n of 4. Or like a 2.
Yes. Doesn't he have to multiply each one by two?
No.
Yes, I do.
Yes.
1 and then 2, 2, 2, 2, and then the last one's 1.
8 thirds. This is the last one with a 10 thirds.
And it's by 1.
And then it's just a single one over here.
Yeah, there you go.
Negative 2 times 4. Holy nightmare.
Stop hearing.
Equals a number.
You know, we can solve that.
Probably something like 1.8.
Yeah, it's going to be
There's a 4 in the
1.8.
beginning of this one also, so 4 times 8 thirds.
That's why I get 4 thirds there.
Oh.
Because you had 2 thirds divided by 2 is 1 third times 4 is 4
The
thirds.
X is different. You're not gonna try a sensor? Why can't you just use this one as a
You
sensor?
just use this and replace the 4 and then 2. I just replace the 4s.
When it still runs like a champ.
What are you doing?
It's a normal hard drive. What is he doing? Over 2x. And then what if you have like a
Is there a
fraction like
DX?
that?
We pull out the file.
Yes.
Don't you
That's
see
points
it?
off. I can't forget that.
This points off.
But yeah, now if you have the fractions and stuff, what the math lab wanted you to do was multiply the pi over 2 by the fraction first, then take the sign of that. And so instead of, because I was making the mistake of this is 1, because sine of pi over 2 is 1, times 5. So it's not 5 times the fraction, it's the fraction times this.
Yes.
Then take the sign of that, and then times 5.
Yes.
And I was screwing that up. So that's
So
something
this
to be
is,
careful
yes,
of.
order of operations where this is the argument of sine, right? So it's sine pi over 2 times x.
So I kept getting that wrong, and I was like, I don't know what I'm doing wrong. And make sure your calculator's in radians too, because if it's not,
Oh yes, guys, I never mentioned that. Thank you.
yeah.
When you have your trig calculations, make sure your calculator is in radians. Otherwise, the whole thing goes to hell.
Yeah.
Yeah, the babies were playing with mine and they changed it and I was doing my whole thing. I was like,
All right.
what the hell's wrong with this?
We're ready.
Ready? All right.
Okay, give
Please
us the
clear the
exam.
desks.
Give us the exam right now. Let's do this. 10 points extra.
Every problem we went over right now.
You're not ready to?
Ready for the exam.
I'm never ready.
All right. Any other questions, concerns?
Again, I'm going to repeat. You are going to make the exam just like the quizzes, right?
I will read you all the quizzes.
That's tomorrow. It's not. I don't worry about it today.
If you do, if
Hell
you make,
no. He's gonna throw some.
no, don't do that. Yes.
All right. Bye.
Oh my God, I've been doing the quizzes. I have 100.